Today we are looking at a brilliant match the following question from Advanced 2024 Paper 1. It combines straight lines and circles beautifully. Let's decode it step by step. Step 1. We have a circle with center 0, alpha, touching the line y equals 2x. The perpendicular distance from the center to this tangent line is exactly the radius, r. Using the distance formula, we get r equals alpha divided by root 5. Since alpha is positive, alpha equals r times root 5. The question gives us a condition. Alpha plus r equals 5 plus root 5. Substitute alpha as r root 5 into this equation. If we write 5 as root 5 times root 5, we can factor both sides to easily see that r equals root 5. Putting this back, we find alpha is exactly 5. This means for list 1, p matches to 4 and q matches to 2. Let's update our diagram. Step 2. Now we need the coordinates of the point of contact, A1. Look at the right-angled triangle formed by the origin O, the center C, and point A1. The hypotenuse OC is 5, and the perpendicular CA1 is the radius, root 5. By Pythagoras' theorem, the base OA1 comes out to be root 20, or 2 root 5. Since the line y equals 2x has a slope of 2, tan theta is 2. This means cos theta is 1 by root 5, and sine theta is 2 by root 5. Using parametric coordinates, A1 is OA1 cos theta, OA1 sine theta. Multiplying the values, we get point A1 as 2, 4. So r matches to 5. Step 3, we are given that A1 B1 is a diameter of the circle. This means the center C 0, 5 is the exact midpoint of A1 and B1. Let B1 be x1, y1. Using the midpoint formula for the x coordinates, x1 plus 2 divided by 2 equals 0, so x1 is minus 2. For the y coordinates, y1 plus 4 divided by 2 equals 5, so y1 is 6. Point B1 is minus 2, 6. Therefore, S matches to 3. Our final matching sequence is P to 4, Q to 2, R to 5, and S to 3. This makes option A the absolutely correct answer. If you found this geometric breakdown helpful, hit that subscribe button for more advanced shortcuts.